So we're looking at lesson 5-2, direct variation. And it says that a direct variation is a relationship that can be represented by a function in the form of y equals kx, where k is not equal to 0. So k is a constant, and it's a constant of variation for a direct variation. And k is also a coefficient. So by dividing each side of y of kx by x, you see the ratio of the variable is constant. It is y over k. So here's the constant ratio y over k. To determine whether an equation represents a direct variation, you need to solve for y. If you can write the equation in the form of y equals kx and k does not equal 0, it represents a direct variation. So let's look at problem 1. It says identifying a direct variation. Does the equation represent a direct variation? If so, find the constant of variation. Well, the first thing they said was solve for y. So we have 7y equals 2x. To get y alone, we need to divide both sides by 7. So we get y equals 2 over 7x. And from this equation, we can see it's in the form of y equals kx, where k in this term is 2 over 7. So it's a constant variation. Let's take a look at b. Again, we have to solve for y. So we're going to first subtract 4x from both sides and get 3y minus 8. 3y equals 8 minus 4x. Then we divide both sides by 3. And we get y equals 8 over 3 minus 4 over 3x. We can't write this one in the form of y equals kx because we have this 8 over 3. So it is not a direct variation. Let's take a look at number 1. The guy didn't do it on her own. So it says, does 4x plus 5y equals 0 represent a direct variation? So let's put it on the board. Okay, so the first thing we need to do is solve for y. So I'm going to subtract 4x from both sides. And I get 5y equals negative 4x. Then I'm going to divide both sides by 5 to get y alone. And I get y equals negative 4 over 5x. So this is in the form of y equals kx, where k is my coefficient, and it is negative 4 over 5. So this represents a direct variation, and my constant is negative 4 over 5. I hope that this helps.